Welcome back to my channel. I am Dr. A. Navanita, Assistant Professor in EC Department, Mahatma Gandhi Institute of Technology. So today I am going to discuss a topic, how the design of digital circuits will be done in the IC fabrication industry, which they are going to use the technology VLSI. So here in this one already we know that VLSI is a growing technology all over the world, which is related to the IC fabrication industry. So here in this one, as we know that this IC fabrication is a $1 billion industry where the GDP of every country is growing. In this one, when we get into the VLSI technology, so VLSI technology, VLSI stands for very large scale integration. Okay, so here in this one, very large scale integration. So what does this technology is going to do? This technology is going to make the circuits, whatever the circuits we have, that is analog circuits and digital circuits, which I explained in my previous video. All the analog circuits, digital circuits and mixed signal circuits, all these circuits are fabricated in electronic component, that is nothing but integrated circuit. So the industry, semiconductor industry, which is related to making the circuits in the form of IC, that we call it as VLSI. So whenever we get into VLSI, three type of circuits will be used. One is a digital circuits, analog circuit and mixed signal circuits. So mixed signal circuit is a combination of both digital and analog. Already I have given in my previous videos what is a digital and analog circuit. So whenever we get into the digital circuit in the VLSI industry, we will discuss among the three. We will discuss about the two, that is a digital and analog. First my video I will discuss about digital circuits. So whenever we get into digital circuits, here whatever the circuit we take, think you are making an adder circuit, okay, in the form of IC. So first I think you are working in a Intel company, and one customer, defense customer, think DRDO company has come to the Intel company to make the adder circuit in the form of IC. Okay, so for that one they have given the power equal to some 1 millivolt and speed equal to 1 gigahertz and area equal to some 20 nanometer, like that they have given. Customer has given the specification to Intel company. So here in this one, whatever the adder circuit is there, that comes under digital circuit. So once they receive the specifications from customer, then the company people will start doing the whatever the circuit they want. How they will start? First, after taking the input, a team of engineers will sit and they will analyze whatever the circuit they want. They want to analyze the circuit, adder circuit. So that adder circuit, after analyzation, they will write the code on after analyzing on the paper design of that circuit. Then that design of the circuit and analysis of the circuit is made into the code form using the whatever the software tools they want. Usually they are going to use the software tools Xilinx, Vivado, or they can make use of Cadence or Synopsys or anything. So to using that tools and using the programming languages Verilog or VHDL, they are going to develop your they are going to develop the program for your adder circuit. Once whatever the program you write for whatever the program you write for your circuits, that program we called as a RTL design, that is nothing but register transfer language. The program which is written, HDL program which is written for the design of the circuit, that is set to the RTL. And in this design, whenever we get into the RTL, two types of two stage of levels will be there. One stage is nothing but design, other stage is nothing but verification. So when you go for design, you are going to write for the adder circuit whatever the hardware description language is there, and whether we can make use of any hardware description language, that is VHDL, Verilog or System Verilog. in the industry 90%, 80% people will be making use of Verilog, and remaining some few people or few countries, European countries, will make use of the VHDL. So mostly is preferred is a Verilog, and 5% can be used with the system Verilog to design whatever the circuit you want. After designing the circuit, once you write the code, what you will do, you are going to check the errors for the code which you have written. After checking the code, what you will do, if your code is error free, you are going to give the input and you are going to check the output. So here in this one, that is set to whatever the functionality you want to check for the circuit for the code you have written, that is set to the verification. Verification is done using two programming language, that is nothing but system Verilog, or they can make use of C++, object oriented program, or they can make use of UVM. UVM is nothing but universal verification methodology. This is the open source one, or they can make use of open source verification methodology. So using this one, any one of them, they can do the verification of your code of this for the circuit which have written. In the verification, what they will do, for given inputs, what outputs they are going to get. Think you have written code for the half adder. Half adder is going to have how many inputs? It is going to have 2 inputs A, B, and 2 outputs sum and carry. So 2 inputs are nothing but A, B, and outputs are nothing but sum and carry. 2 inputs means 4 combination, 0 0 0 1 1 0 1 1 you are going to have. For 0 0, what is the output sum you are going to get here? Sum 0, carry 0. And for 0 1, sum 1, carry 0. 1 0, sum 1, carry 0. 1 1, sum 0, carry 1. Isn't it? So here in this way, we are going to check the verification by writing the code using system Verilog or object oriented program, or using the methodology of universal verification methodology. So here in this one, after checking different inputs, whatever the output you get, that comes under your simulation. Once the simulation is over, next we are going to check, go for the synthesis. In the synthesis means what? Whatever the code you have written, for the code written, gate level circuit, whatever you get, that conversion of HDL code into gate level circuit, that we call it as a synthesis. So if you go for half adder is going to have what? It is going to have XOR gate, isn't it? And it is going to have AND gate. Here 2 inputs it is going to have, isn't it? One is A, another one is nothing but B, and the output which you are going to have is nothing but sum and carry, isn't it? So here in this one, conversion of this code written into hardware hardware circuit, we call it as what? Synthesis. Next we get implementation of your adder circuit on FPGA. FPGA stands for feed programmable gate array. It is an IC which is going to contain circuits which is going to contain multiplexer, control logic circuits, lookup tables, logic gate circuits, sequential circuits will be there. So here in this one, this circuit will check whatever may be the logic of the program. That logic of the program through hardware means you are going to check on this IC. Okay, example you can take Spartan 3 and Arctic 7, isn't it? Vertex 3. All these FPGAs are there. So you on this FPGA, whatever the code you have written in the VHDL or Verilog, it will be converted into ones and zeros, binary bit program. That binary bit program is made to put on this FPGA. After made to put on the IC FPGA on the development board, on the development board you are going to give the inputs and check the outputs. Inputs what you are going to give for half adder A and B, you are going to give 2 switches will be used, and outputs you are going to check on the LED. So here 2 inputs means 4 combinations you are going to use. When the switch is off, it is 0, when switch is on, it is 1. So 4 combinations, 0 0 0 1 1 0 1 1 it will be given, and for outputs sum and carry, 2 LEDs will be made use. So here for 0 1 1 if you take, if you get the sum, that is LED off, and carry 1, with that on the board only you are going to check out. Okay, so in this way whatever the code developed and verification, that is giving inputs and outputs, which comes under simulation, is done, and synthesis gate level circuit which you got, and conversion of that code into binary bit program 1 and 0 on FPGA. All this design till writing the code till FPGA comes under front end design of VLSI. Okay, front end design of VLSI. So here in this one, and whatever the code you have written, it will be only with the gate level. Every gate level is going to be consisting of transistor. So conversion of these gate level circuits into transistor level circuits, that is nothing but CMOS circuits, and again each transistor is made up of semiconductor level. That conversion of transistor level circuits into semiconductor level circuits, that is nothing but layout. That layout will be converted into textual conversion, that is a GDS tool, the GDS file they will say. That GDS file will be given to the fabrication engineer. That fabrication engineer taking the GDS tool, taking the physical semiconductor material, and he will make the circuit in the form of IC. So whatever the gate level circuit is a conversion into transistor and semiconductor level layouts, making into fabricating the layouts into the chip form, packing, marketing, everything from transistor conversion into till the end of chip fabrication, all this will be coming under your back end design. So this is how your digital circuits for front end back end will be done. In the next video we will check out in the analog circuits how it is going to be done. So here, whenever, one thing you have to remember, whenever you are checking on the FPGA, only digital circuits are only used to check their logic on the FPGA. Analog circuits you cannot be used. So if these FPGAs are integrated with DAC or ADC, then you can make use of FPGA for checking your logic of analog circuit. But most of the 90% FPGAs will be without DAC and ADC, and in that case you can check only the logic of your digital circuits only. Okay, so I think I have given lot of information regarding the how the front end design and back end design of VLSI will be done, which is a growing industry in the semiconductor. In my next video I will discuss about analog circuits. If you like my video, subscribe it, put a comment and click the like button. Thank you once again.